For our homework notes tonight, we're going to be talking about measures of dispersion. Okay, so there's a lot of some weird looking formulas going on, but we're going to simplify it as much as possible using our calculator. So first we need to define dispersion. So what is dispersion? What does it mean? Well, if something is dispersing, it's spreading out. So dispersion is just talking about how data is spread out in relation to the mean. So how data is spread out out about the mean. And remember from class today, the mean is talking about the average value. Okay, so once we know our average value, we can look at how the rest of the data is spread out compared to that. Is it super close to the mean? Is it pretty far away from it? All over the place? So then there's a couple ways we can figure that out. So first one is called mean absolute deviation. And mean absolute deviation, we can abbreviate this just by its initials, the first letters of each word. So we call it the MAD. And the MAD is the average distance of each data value from the mean. So it's the average of how far each data point is from whatever the mean is of the data. So the average distance of each data value from the mean. Okay. And it's found by this pretty crazy looking equation. The next thing we're going to talk about is standard deviation, and we usually see this with this little symbol here. So this is a lowercase sigma, but that's how we usually see it. And it's talking about how it's a value that shows how the data deviates from the mean, so how it's different from the mean. Okay, and we'll see this when we use a bell curve. So again, standard deviation, it's just a value that shows how data deviates from the mean. And we'll see this when we look at bell curves. So bell curve. And then the last thing is variance. Variance is the standard deviation squared. Okay, so that's really all it is. It's just standard deviation squared. And we have these really ridiculous formulas, but our calculator is going to help us do all of the work, but much more quickly without as many confusing formulas, okay? So we're going to do the first data set together. So use the following data sets to calculate the measures of dispersion. So we're going to find the mean. And remember in our calculator, when we look at the stats, the mean is actually written as x bar. The MAD's the mean absolute deviation. Our standard deviation, or that sigma, and the variance, which is sigma squared. So we'll use our calculator to figure this out. So here's our data set. And the first thing I'm going to do is I'm going to enter that data into the calculator. So remember, we go to, if you're in anything else, just clear out of it. We go to Stat, Edit, and then any list that you currently have you want to clear. So you go up to the title, and let's clear it, and then you can hit enter or scroll down. And let's go ahead and type in our data points. So we have -10, 0, 10, 20, and 30. And I'm just going to double check and make sure that I got all of the correct data points, because one of the biggest mistakes we make in statistics, it's not by writing something down wrong from the calculator, because the calculator does all the work. It's inputting our values incorrectly. So we've got -10, 0, 10, 20, 30. Awesome. Okay, so from here we can calculate the mean. We go to Stat, Calc, and 1var Stats. We want L1. We're going to calculate it. So let's go ahead and find our mean. Our mean is x bar, so our mean is 10. So we can say the mean is 10. The next thing we're looking for is the mean absolute deviation. So let's just think about what it actually represents. Remember, the mean absolute deviation, or the MAD, is the average distance of each value from the mean. So think about the distance from each point to the mean, okay? So the mean was 10, so we're thinking about the distance between those. So what's the distance between -10 and 10? Well, on a number line, it's going to be a distance of 20. Okay, how about from 0 to 10? Has a distance of 10. From 10 to 10, that has a distance of 0. From 20 to 10 has a distance of 10. And from 30, it has a distance of 20. So all of our distances, all of these numbers are going to be positive, because distance is a positive value. And again, it's the distance from the mean. Distance from the mean, or x bar, okay? And the mean absolute deviation, it's the average distance of each value from the mean. So we're going to add all these values up, and we're going to take the average of them. So I find the sum, and then I divide it by the number of values. 1, 2, 3, 4, 5. So I'll divide that by 5. So we can do that in our calculator. We've got 20 plus 10 plus 0 plus 10 plus 20, and then we're going to divide that number by 5. Okay, so this tells us that our mean absolute deviation, our MAD, is going to be 12. So again, we looked at the distance between this point and the mean, this point and the mean, and all that, and then we took the average of those. All right, our standard deviation. So standard deviation, this is actually something we can just find from our calculator. So remember how we put all that information into our stats, our list? Well, we'll just go to Stat Calc, 1var Stats again, and this is going to tell us our standard deviation. Notice standard deviation on our paper, it's got this little sigma. In our calculator, they just put it as sigma x. Okay, so it's written as sigma x in the calculator. And our calculator will tell us our standard deviation. In this case, let's round it to the nearest tenth, so we'll say it's 14.1. Okay. Lastly, the variance is standard deviation squared, so it's just this number squared. So I'm going to show you how you can get the exact value. You can certainly do 14.1 and then square it. That's one way to do it. But you could also get a more exact value this way. If you go to vars, so it's like variables, so vars, then statistics, so I'm going to go down to 5 statistics, and then I want the standard deviation, right? So I'm going to hit 4, and I'm going to square it. That's going to give me a more accurate value based on the number that we had. So really you could answer it as 198.8, or you could say 200. I would accept either one of those. Okay. And you could just put 200, not 200.0. Okay, so again, to find that standard deviation value, this is also true if you ever want to find the mean. You can do vars, and then statistics, and then there's your mean. Okay. One thing I want to show you is, so looking back at when we found the mean absolute deviation, we wrote it out this way, and you can certainly do that. It's always going to work. But let's say you have a bunch of numbers, like you might have a data set that has like 20 different numbers. It might take you a little while to find the difference between each data value and the mean. So here's a way you can do it in your calculator, okay? So we go to Stat and Edit, and notice we have our original data values in L1, so -10, 0, 10, 2, or 20, 30. Then what we're going to do is we're going to go over to L2, and we're going to highlight L2. Now, the mean absolute deviation is the average of the distances between each data value and the mean. So we need to find the distance between each data value and the mean. Here's how we do this. Distance is the absolute value of the difference between two numbers. So I'm going to highlight L2, and I'm going to go to Math, Num, Absolute Value. Okay, so that was Math, Num, Abs. And we want L1, so second one, minus the mean. So what was the mean that we found? 10. So we're going to do that minus 10. So this is saying that for L2, this is going to be a list of the distances between each number and the mean. So let's check out the numbers they gave us. 20, 10, 0, 10, 20. 20, 10, 0, 10, 20. And aren't those the distances that we found anyway? So if we want to calculate the mean, we have to find the average of these numbers. So just like we found the average of the original list, we go to Stat, Calc, var stats, but this time we're looking at L2. So we're going to do second 2. So now it's going to calculate all of these statistics for L2. First thing it tells us is the mean is 12. Mean absolute deviation is 12. Okay. So we can do the same thing with this next one. So we have data set B. So we can go back to our Stat, Edit, and let's clear out all these lists. So go up, hit Clear, and then down, Clear, then down. And let's go ahead and enter in our data points, 8, 9, 10, 11, and 12. 8, 9, 10, 11, 12. Okay, so I'm going to make sure that I plugged in everything correctly. 8, 9, 10, 11, 12. We're going to go to Stat, Calc, var stats. Make sure that you put the correct list. Remember we changed ours to L2, but we put this in as L1. So we need to put second 1. Let's make it L2, or I'm sorry, L1. Then we'll calculate. Okay, this tells us that our mean is 10. So our mean is 10. Our standard deviation, remember that sigma x is 1.4. Our variance is just that number squared. So our variance, if we quit, we can either say 1.4 squared and get 1.96. Or to get a better number, you can do vars. Remember, vars is right there. Vars, statistics. We want the standard deviation squared. And 2 is going to be the more accurate number, just like 200 was the more accurate number of the first one. Okay, so the last thing we got to find is mean absolute deviation. So we're going to go back to our Stat, Edit. Let's go over to L2. So it's the distance between each of these numbers and the mean, which is 10. So we go Math, Num, Abs, absolute value of L1, so second 1, minus the mean was 10. And this should tell us the distance between each number and 10. 2, 1, 0, 1, 2. Now we're going to find the average of these values. So we can do Stat, Calc, var stats, but this time we want to check L2. So second 2, calculate, and our mean is 1.2. Okay. Again, if you don't want to do it that way, you can just list it out like we did before. So you can list out the distances between each of these and 10. So the distance between 8 and 10 is 2. This is 1, 0, 1, 2, and then we're finding the average, so divide that by 5, and we'll get 1.2. Okay, I hope this helped. Make sure you use the rest of your notes to answer the final questions, and then look out for the Google form to submit your answers.